right, everyone. Welcome to our last lesson of Unit 2, Part 1 with transformations, and that's talking about our composition of transformations and doing more than one transformation at once, basically, is what we're looking for. So we're going to start with a little bit of review here. And it says, recall that a rigid motion has the same shape and it also has the same size, right? When we perform one of our rigid motions, we do not change the shape or size of our figure. Dilations, which we haven't spent much time on yet, are not a rigid motion because they will change the size of our figure. So dilations we'll focus on a little bit later, but they're not a part of our rigid motions. Transformations of shapes that are rigid motions, however, are our translations, our reflections, and the rotations that we talked about previously throughout Activity 9. Now, to review a little bit with rotations, reminder that a rotation 90 degrees, where the 90 inside of here is positive, is a little bit backwards from what we're probably thinking. This means that we have a counter rotation, which means that our figure would rotate to the left in our picture versus when we have a negative 90 in that rotation notation. We have to rotate 90 degrees clockwise. So again, these are a little bit backwards from what we think normally. And again, that means that it would rotate to the right or down. When it is written inside of the parentheses, again, we have to think about that it's basically the opposite of what it looks like to us. Now, a reflection over the y-axis written like this means that we are reflecting a point over our y-axis. And basically what happens with this then is we end up changing when we reflect the y-axis, we change the sign of the x value, right? Because we reflect over the x-axis, or excuse me, the y-axis, that's this axis here, so we end up changing our x value from positive to negative, basically. As opposed to when we reflect over the x-axis, we're going to change our y value. So in that particular one, we have the reflection over the y-axis, excuse me, the x-axis, that's this axis, and we end up flipping the sign of our y value since we're moving up or down kind of with that reflection. Last but not least, this giant T, this stands for our translation. And we move x units left and right. So positive is right, negative is left, right? So negative is left, positive is right. And we also then would move our y units up or down. So down is the negative in this case, and up is the positive in this case. And that would be affected by this piece here. So we're going to use those notations in order to we'll look at our double transformation, which we always want to perform whatever the second one is first. So you go from the right to the left. So in example 1 here, we're starting first here, and then second would be this piece here. So we always read right to left on these. So the first thing that we would be performing in this particular one is the rotation around the origin, 90 degrees, counter. That's our first one here. We're rotating 90 degrees counterclockwise. Now, that means then the second piece is this translation. And according to this translation, we are translating 3 units to the right, since our 3 is positive, and 2 units up in that particular one, represented by the 3 and the 2. Now on the second example here, we want to look at this, and our first one this time is actually going to be the translation, because again, we always go right to left. Composition of functions, we always start with the inner function, same kind of idea here. So this time what we're going to do is we are performing first the translation left 1 unit, since it was -1, and up 6 units. And then we're going to take that transformed point and we are going to perform the second operation, which is this rotation. So this time we are going to perform rotation at 90 degrees clockwise, if it was -90. Let's try this next one on your own to start. And again, you should have started first with this rotation. So we would have a rotation 180 degrees around the origin. And that means then second, what we're doing is we are going to perform that reflection. So we will be performing the reflection over the x. Now the next piece of this is actually performing that. So notice we're going to start in example 4 with point A, which is located at 2, 1. So right 2 up 1 is point A. And it's translated using the rule given, and then it's reflected over the x-axis. So if we're going to write the function rule to describe this, we're going to start by writing the translation to the right 2 and down 5. So 2, -5. Now, since this is what's being performed first, it's actually going second. So it's going to go to the right, and then our reflection over the x-axis is what's coming second. So little r to represent that, and then over the x-axis would be our next piece here. So what we need to do first to our original point A is starting at 2, 1, we need to move to the right 2 and down 1, 2, 3, 4, 5, so that we end up over here at 4, -4 is A prime. And then we need to perform that reflection over the x-axis. So now I'm going to use that point I just transformed, and I'm going to reflect it over the x-axis so that I end up 4 units to the other side of that at A double prime. So really my point after the translation was at 4, -4. But then after the reflection, double prime ended up at 4, 4, which is my final answer after the transformation. Let's try another one. This next one wants us to reflect this point A first over the x-axis and then translate it 2 units up and 3 units left. So again, to represent this, we are first going to look at our first transformation, which is this reflection over the x-axis. So we're going to start here, reflection over x-axis, and then translation 2 units up and 3 units left is our second piece. So translation 2 up and 2 up would have to go second, excuse me. So it's a common mistake to want to make. The 3 units left is -3 and then the 2 units up. So make sure you're very careful on that because we have x -3, y +2 on this one, that we don't accidentally switch those because left always comes before up. Okay. Now, our original point, they said, is at -2, -4, which is point A here. And what we want to do now is start again by first reflecting it over the x-axis. So here's my x-axis, and I need to be the same distance from that x-axis on the other side. So really, I'm at 2, 4. in this particular one. This is my A prime is at 2, comma 4. Excuse me, negative 2, comma 4, since we're still to the left. Now, the next piece after that is I want to take that A prime and I need to move it to the left 2 and up, sorry, left 3 up 2. So I'm moving 1, 2, 3 to the left and then 1, 2 up so that I ended up at this value here, which is at negative 5, comma 6. So that's the location of my double primes is at negative 5, comma 6. All right, try the next one on your own to start. You should hopefully have written down that your first piece here is that you're going to translation down and to the right. So that translation comes first and it's to the right 3 units, so plus 3, and then down 5 units would be represented like so. And then your reflection over the y-axis would be written to the left, since that's what we're performing second, and we just say reflection over y-axis. So this time our point is originally starting at negative 5, 7, so it's to the left 5 and up 7. Here's point A, and we're again going to start by translating it 1, 2, 3 to the right, 1, 2, 3, 4, 5 units down. So here's A prime, which is going to be located at negative 2, comma 2. Now, the next piece wants us to reflect it over the y-axis, which is this one right here. So we were 2 units from the y-axis, which means we need to be 2 units on the other side as well. So again, switching that x value from negative 2 to positive 2, since it reflected over the y-axis. This then would be your final location of a double prime after the double translation. Last but not least, we are looking here at this segment AH, and it's being, it has a length of 6.3 units. So there's the coordinates, that's the length. It's rotated and then it's translated. How long is A prime, H prime? Well, reminder, these are both rigid transformations. So what we're actually going to find out is that this is still going to be 6.3 units. And the reason being, the rigid transformations do not change size. So going back to what we talked about before with diagonals and things being the same, if these are rigid translations and transformations and rotations, they're all rigid, we're not going to change the size. It's going to be the exact same as it was in the original. What do you think about number 8 after you read that? What do you think is going to be the length of our transformed segment? Well, hopefully you notice that this is, again, just going to be 12 units long. All right, and again, the reason being is the reflection is a rigid transformation, so it's not going to change the size of our figure. Okay, we'll work more with this in class. Make sure you guys are fully done with all of your videos and have a great rest of your day.